Assalamualaikum and good day to everyone. Okay, today I will teach you on chapter 3, which is a DC machine drive. Okay, in this chapter, I will give a brief introduction about the DC machine, and then we will learn how to start the DC motor, and then how to control the speed and how to brake the DC motor. Okay, as you know, in DC machine we have a two type, which is a DC motor and DC generator. But in this topic, we just cover on a DC motor. Okay, a DC motor is any of a class of rotary electrical motors that converts direct current electrical energy into mechanical energy. And the most common types rely on the forces produced by magnetic field. Okay, DC motors are categorized in a number of types based on the input supply, construction, and principle of operation. Mainly, there are two types of DC motor. Okay, first one is separately excited DC motor and self-excited DC motor. And then the self-excited motors are further classified as shunt DC motor, compound DC motor, and series DC motor. DC drives are widely used in applications requiring adjustable speed, good speed regulation, and frequent starting, braking, and reversing. And some important applications are rolling mills, paper mills, mine windows, hoists, machine tools, traction, printing presses, textiles mills, excavators, and cranes. And fractional horsepower DC motors are widely used as servo motors for positioning and tracking. Okay, although since late 60s, it is being predicted that AC drive will replace DC drive. However, even today, the variable speed applications are dominated by DC drive because of low cost, reliability, and simple control. Okay, next, the DC motor comprises four principal components. The basic working principle of a DC motor is whenever a current carrying conductor is placed in magnetic field, it experiences a mechanical force. And when armature windings are connected to a DC supply and electric current setups in the windings. So, in this figure, you can see the four components of DC motor is field, armature, commutator, and brushes. Okay, as I mentioned before, when armature windings are connected to a DC supply and electric current setups in the winding, magnetic field may be provided by field winding or by using permanent magnet. We have a permanent magnet here. And in this case, current carrying armature conductors experience a force due to the magnetic field according to the principle stated above. Okay, and then we have a conductor here. Conductor here carry a armature current. And then commutator is made segmented to achieve unidirectional torque. Okay, otherwise the direction of force would have reversed every time when the direction of movement of conductor is reversed. in the magnetic field. This is how a DC motor works. Okay? And according to the fundamental laws of nature, no energy conversion is possible until there is something to oppose the conversion. Okay, in case of generators, this opposition is provided by magnetic drag. But in case of DC motors, there is back EMF here. Okay, and then when the armature of a motor is rotating, the conductors are also cutting the magnetic flux lines, and hence, according to the Faraday's law of electromagnetic induction, an EMF induced in the armature conductor here. Okay, and then the direction of this induced EMF is such that it opposes the armature current. Okay, armature current will flow here, and then we have a flux from north to south. Okay, as we know, energy neither can be created nor it can be destroyed. It can only be transferred from one form to another. And in DC motor, electrical energy is converted into the mechanical energy. And then during this process, the total input power is not transformed into output power. Some parts of input power gets wasted in various forms. The form of this loss may vary from one machine to another. These losses give in the rise in temperature of the motor and reduce the efficiency of the motor. This is somewhat you feel that your motor is getting hot. Okay, and in DC motor there are broadly 4 main categories of energy loss. Okay, the first one is electrical losses or copper losses, or we can call it a winding losses. Okay, the copper losses are the winding losses taking place during the current flowing through the winding, armature and field winding. And these losses occur due to the resistance in the winding. Means that we represent the winding as a resistor. And in a DC machine, there are only 2 windings, armature and field winding. Thus, copper losses categories in 3 parts: armature loss, the field winding loss, and brush contact resistance loss. The copper losses are proportional to the square of the current flowing through the winding. Okay, and then we have a mechanical losses. Okay, the losses associated with mechanical friction of the machine are called mechanical losses. These losses occur due to friction in the moving parts of the machine like bearing, brushes, and windage losses occur due to the air inside the rotating coil of the machine. And these losses are usually very small, about 15% of full load loss. And then we have core losses, or we can call it iron losses, or we can call it magnetic losses. Okay, as iron core of the armature is rotating in magnetic field, some losses occurs in the core, which is called core losses. Normally, machines are operated with constant speed, so these losses are almost constant. And these losses are categorized into form, which is hysteresis loss and eddy current loss. Okay, please find by yourself what is the hysteresis loss and what is the eddy current loss. Okay.